Okay. Okay, we started. Good. So we'll begin today. So we have till now done maximum likelihood estimation. We have done maximum a posteriori estimate. We have learned linear regression, and we have seen how linear algebra and statistics can be used extensively in machine learning. These are the four things. And we also used discriminant functions. So we have done quite a bit of supervised learning by now. Today, we are going to start and delve into a very interesting problem, which is we have done some of it when the discriminant function, we try to take decisions and actions. But here we'll be trying to categorize the data into different classes. Say, for example, you have two classes, cats and dogs, but you have data in form of images. Data is image. The humans would be able to look at the image and tell whether it is a cat or a dog. Similarly, we want the machine learning model to also say it is a cat and a dog or a dog, depending on the image that is shown to it, right? So whenever you show the image of a dog, the model should tell me that it's a dog that is being shown, and similarly for cats. So, but the question arises, and this is where we'll be seeing how beautifully we can use all the distributions that we have learned and the techniques of statistical techniques like maximum likelihood estimation that we have encountered in the previous course. So first, it's good to understand this picture very well. So if I give you this picture and you see there are circles, that is say class 1, these are dogs, for example. I hope I'm audible, right? Okay. So these are cats and these are dogs. So we want to pass a decision boundary, as we had seen in the example that I told you to solve. We had solved it and I told you to plot the decision boundary. I want to I want to demarcate the data into two parts of the plane. So I want to say divide the upper half and lower half of the plane, right? So the question arises, how do I do that? How do I divide the data into top and say it is dividable between two parts? Say it's linear. So do you agree that if you have a equation of a line like this, and if the data is linearly separable, that is a line can separate them, say class 1 and class 2, then do you agree that if there is this line has an equation ax plus by plus c equal to 0, say L of xy equal to 0, so then one side of the line L of xy will be greater than 0 and the other side will be less than 0, right? Yes or no? So if this line is ax plus by plus c equal to 0, then above one side of the line will be greater than 0 and one side will be lesser than 0, right?
Yes.
Okay. So the idea is if I can make a model, so if I can get this as my model, so what will be the model over here? My model will be A, B, and C, right? A, B, and C. If I can get the values of A, B, and C, I'll put the feature X. X is the feature, right? Or rather X comma Y are the feature. And I'll get a decision, right? So what decision will you take? So L of XY greater than 0, you will say class 1. And L of XY less than 0, we will say class 0, right? Or cats and dogs, or class 2 here, dogs, right? Let's write 0 for consistency. Okay, clear? I hope it is clear, right? So if we are able to get somehow know the values of A, B, and C, we'll be able to solve this problem. But in a higher dimensional space, what will happen? In a higher dimensional space, similarly, instead of a line, we have seen in linear algebra, it will be a plane, right? Yes or no? And this will be its W vector perpendicular to the plane such that W transpose X will be equal to 0. And I'm putting the 0 purposely on it. I'll show you why. Right? If the equation of a plane, so on the equation of the plane, W transpose X is equal to 0, right? W is the weight vector. So for example, if you have a 3D plane, a plane in 3D, what is the equation? Ax plus by. Okay, sorry. So if you have an equation in a 3D, you have ax plus by plus cz is equal to 0, right? Yes or no?
Yes.
Ax plus by plus cz equal to 0. So you have a, b, c and x, y, z. So data will be, this will be your data and this is your parameters. So this is W transpose X is equal to 0 is the line. So anything above the line, W transpose X greater than 0, I'll say class 1, and W transpose X less than 0, I'll say class 2, class 0. Now my question is, what is W transpose X and what is X? These two are the things that I want to learn. Say you have data points over here in this higher dimensional space. You have class 1 and class 0. My question to you is, what is X? First question is, what is X? Say for one data point, for one. So first my question is, what is the data that is given to you? What is the data given to you? This is my first question. Data is given. What is it given? So you're given x comma y, right? From I equal to, say you're given n examples. And x is an image of a cat or a dog. And y is 1 if it is cat, 0 if it is a dog. Okay. Any questions? Okay. So what I'll do is I'll have to learn W such that W transpose X is equal to. So this is my decision boundary that I'll learn. D of X is equal to W transpose X. But how will I learn it? So this D of X, the X that is given, what is, how many dimension does it have? Say so this images may be say 64 cross 64 cross 3. How many dimensions will they have? R 64 64 3, right? This is the number of points every image will have, right? Every image will be a vector, right? X1, x2, dot, 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 x64 cross 64 cross 3. Is it clear? And I want to learn, say,
Yes.
say this is our D features. It would be useful if you could like stop me or ask me questions when there is some, we have reached a landmark. Okay. So my question is, so with this, I get W1x1 plus W2x2 plus W dot 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 Wn or WDXD, right? Say we are doing it for the ith example. I'll write I on the numerator or on the superscript so that there is no confusion regarding the notation. So what is this notation? Can you tell me? Wxi of j.
Like jth feature of ith example.
Jth feature of ith training example. So now, can you tell me if there is a problem with this? Just taking linear combination of the features. There's one problem with this. That is, if the data has some offset, right? That is some W0 intercept, correct? So I need to add W0 to it, right? So how do I add W0 to it? I convert X to X0, X1, X2 dot 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 XD, correct? And X0 will be equal to 1 always, right? If I add a 1 in the beginning, I will be able to, when I multiply W, take the dot product, I'll get W0, right? W0, W1, WD. I hope it is clear. And this is why I took the origin in the center. This is R D plus 1 dimensional, right? The origin will be contained in it. Yes or no? The origin must be contained in the D R plus 1 dimensional vector. So whoever is joining me late, what I'm trying to do is I'm trying to divide data that is linearly separable in by a line. And we know that a line divides the plane into a region where it is greater than, the equation of the line takes values greater than 0 and values less than 0. So I can simply take decision based on the value of the line evaluated at those points. So all I have done is, for each feature, I have taken a linear combination of all of these features. That's what exactly I have done, right? Now my question to you is, how do I learn W's? What is my procedure to learn these W's? So what did we learn last time? We learned MLE, right? We learned X comma Y given theta. We would like to maximize it, right? This is what we are going to use MLE, say, using maximum likelihood estimate. My question, I have already given you the model. I want to know how to train the model. That's the idea. So any idea, how do I train it? What is the maximum likelihood formulation? Theta star is argmax of
Argmax of P of X comma Y,
argmax of
P of X comma Y such that theta.
okay. So give it data given the parameter, right?
Hmm.
We were trying to fit the
Yes.
parameters, the best parameter that explain the data. So data was, say, D is here, and parameter. So whatever is, say, this is the parameter that explains theta best, we'll select this parameter. Okay. Now my question to you is, but I don't want, do I want X comma Y or do I want something else? I will just give you a hint. Do you think I want this? And you will tell me, why do I want this? So, and I'll take log probabilities, right? It is useful to take logs. Yes or no? So we took
Yes.
log likelihood. This is a log likelihood.
Hmm.
Now, if this is a log likelihood, I will just reformulate slightly. X comma Y comma theta divided by theta. I will divide by P of theta comma Y or X and multiply by P of theta comma X. Is this step clear? No doubts?
No.
So what will this become? Argmax of theta log of P of Y given X comma theta into probability of X given theta. Is it agreeable to all of you? I hope this is clear to everyone. I'm just putting the expectation to at the end divide by 0. It is not going to change anything because we had shown that doing maximum likelihood was equivalent to minimizing the scale divergence, right? Expectation is nothing but taking the average. That's it. Instead of taking the sum, I'll take average. So I hope this is clear. But now if it is clear, tell me what is this term? Does this depend on theta in our model? Does this have to depend on theta?
তো p of x হয়ে যাবে কারণ
So
distribution
in
of
our model,
the
our
is
choice,
independent.
yes, our choice is x given theta is equal to probability of x. This is our choice, design choice. You can make models where you take the likelihood of x as well. But here our choice is we will not take, right? And therefore, this is just a constant. So I can write this as argmax of theta. Very important. That's why I'm writing it in green. Log of y given. Yeah.
এই এক্সপেকটেশনটা কেন নিলে গো বুঝলাম না।
See, normally it will be a sum. Here it will be, I'm taking an expectation. You recall I did KL divergence, right? We showed that KL divergence was equivalent to, if you recall, this was your KL divergence definition. Where is the KL divergence definition? This was your KL divergence definition. And we showed that that was equal to this. Yes or no?
Oh, acha.
And your log likelihood is just this term without dividing 1 by n. So expectation will just make the thing much more stable compared to just taking the sum, which can blow up. Always good to take expectations. But if you are not getting it, you may not have revised your KL divergence. KL divergence, we discussed that it was trying to minimize the distance between the two distributions, right?
Okay.
So log likelihood and KL divergence was the same thing, right? Log likelihood is just this term. KL divergence is adding this, averaging about them. It's not going to change anything. Just a constant, dividing by a constant.
Fine.
Again, I'm not again, this was your normal log likelihood dividing by 1 by n. So normally when I'm taking, so when I'm taking this expectation, what is it expectation over is my question. It's an expectation over the data set, right? Normally you are
Yes,
taking
so
P
x,
of,
y.
yeah, normally you are taking probability of x given theta, right? Here x is data, this is your data set, total data set. Total data set. So you do it IID and say P of xi given theta.
Yes, class conditional independence.
Class conditional independent, not class conditional. All the data points are IID from the data distribution.
Yeah.
IID data points. So instead of doing this, what can I do? I can take the expected value of probability, log probability or probability of x given theta. Here it is not the data set, but one sample. Right here it is both turn out to be the same thing. When I'm taking expectation, x is over P of x. Which means it is 1 by n summation of I equal to 1 to n P of x given theta.
If it is finite, then it is average, infinite expectation.
Yes, but for that it has to be log likelihood. Only log likelihood case will it be sum. Not for finite also. Finite also you will divide by a finite number 1 by n because you have only samples from the data. So you will be taking a sample average. Both are the same thing. When here x and y is sampled from the data distribution, other case x and y will come up because you will take IID case. Both are same.
মানে এটা তো বেসিক্যালি এটা ওটার unbiased estimatorটা.
Yes, this is exactly the unbiased estimator of that. One point is the unbiased estimator.
Oh, clear.
Yeah. So therefore our model is theta star is argmin of x comma y from the data distribution. Expected value. If you're not able to understand what is the data distribution, don't worry about it. I'll write it. Data distribution is nothing but the data. We do not have the actual data distribution. Then what will I do? If I do not have the actual data distribution, what will I do?
I'll try to estimate it.
Sample estimate. We have done law of large numbers.
Yes.
I equal to 1 to n. Probable log probability of. See, it becomes the same thing. Yi given xi given of theta, right? Is it clear? Now this is useful. Can you tell me why? I have written it in terms of probability, but I can bring my model now. Why? Why can I bring the model? So I have the idea is y depends on x now, right? Y depends on x. That's what you want. You want to give the value of x and tell y. Given x,
না
that is
মানে
data.
আগে কি অসুবিধা হচ্ছিল?
You were doing joint distribution now previously. This was joint.
হ্যাঁ,
X comma y given theta is a joint distribution. So you
হ্যাঁ,
have to estimate the entire distribution together. But here you can just give the x to me and tell me what is the value of y. Here you will have to take
মানে
it for
আমাকে
all pairs. How will you do that otherwise? Both are equivalent. We have shown both are equivalent under the assumption that x is independent of theta.
আচ্ছা,
X comma y are the labeled samples, right? You want to estimate the label of the data given x.
given x, yes.
What is the objective given image, which is x? You want to save cat or dog, which
Cat
is
or
y.
dog, yes.
So that's what the log, that's what P is saying, right? Probability of cat or dog given the data.
হ্যাঁ,
That's
হ্যাঁ,
what
হ্যাঁ,
I've
হ্যাঁ,
written.
ঠিক আছে।
That's
Yes,
what I've
yes,
written in
clear.
terms of probability. That's what I have got. Now I can represent this model in terms of a distribution. How can I do that? What can I do with P of yi given xi comma theta? I need to represent this. It's some distribution, then only I can write the loss function. Some particular case. So there are two classes here, right? Two classes. So this is called a binary classification problem. Binary classification. So how many values are possible? Y equal to 0 or y equal to 1, right? Correct. So if a model, so till now I was saying there will be a model D that will give me linear combination of these values, and greater than 0 will give me what? Class 1, and less than 0 will be class 0, right?
Yes.
Yes.
So now I will tell you, why not make it Bernoulli? Yi is the variable. What is the parameter? Parameters are, so theta is
W.
W. Theta is W over here. Okay. So I'll just write W here. Good. Okay. So what will I write? I will write W transpose Xi. Now you see. So this is my probability. If I can say W transpose Xi is the probability of Xi being in class, which class?
yi.
Yi. What values
না,
can Yi take?
না,
It's
class 1.
dogs, I think.
1.
Yes.
Good. It's a Bernoulli P distribution. Bernoulli, so probability of Yi equal to 1 given Xi. See how nicely we are using this probability. That is equal to W transpose X we want, right? Yes or no? That is the probability. This is P that Bernoulli P used to write. See, this extra term is the
Yes.
variable, random variable. This is the random variable. It is useful to write the random variable in machine learning because you will have a lot of random variables. Just to keep in mind, I have written that. Parameter is W transpose X. But now, if you have understood what I said, W transpose X cannot be a probability. Can you tell me why?
Because it can't lie between 0 and 1.
This is belong to real number and not between 0 and 1. So I have to convert this somehow to 0 and 1. But I can do that. I'm not hopeless, right? I know something, right? If W transpose X, I is less than 0, I am confident, more confident that it is in cat class, right? Class 0. And I know W transpose Xi greater than 0, I am confident in class 1, right? These are the two things I know. No doubts. So, but therefore, I want to convert everything from minus infinity to 0 to which probabilities? 0 to 0.5. Yes or no? All values between minus infinity to 0, that W transpose X values, I want to convert to which values? Since it has to be probabilities, 0 to 0.5. And greater than 0, I want to convert to 0.5 to 1. Is it clear to everyone? If it is not, I'm waiting for a second. Ask.
Acha, we used, I guess, in the probability exercises, we had used some f tilde inverse function. So
We can
that
do
also,
that.
I guess,
We can do that, but there is a very simple function to do it. That's called the sigmoid function. You'll get that. Sigmoid function. Let us understand what is a sigmoid function and then we can apply it here. I think you have all used sigmoid functions. This is a very special question in all calculus books. If I write this function, what are the range of values it takes? Let us just three points. Yaosh Mitchell.
0 to 1.
0 to 1. Okay. At sigma 0 is 1 by 1 plus e to the power 0, which is equal to half, right? At 0, it is half. At minus infinity,
0.
sigma minus infinity, this is equal to 1 by infinity equal to 0. Similarly, it goes to 0. Sigma infinity is equal to 1 by 1 is equal to 0. Is equal to 1. So the graph, something you can also take the second derivative, it looks like this. Right? Is this okay? Now, if I just put W transpose X via this sigmoid function, I will be done, right? Is it clear to everyone?
Yes.
So I will just, so I'm going to put sigma everywhere. So this is my probability. Any doubt? So I'll just pass minus infinity to 0 through sigma. I'll get between this. I'll pass it through sigma. I'll get 0.5 to this. Now I will put this back. So I know the probability now. It's a Bernoulli, right? Now where will I put it back? Which equation will I put it back?
কি মানে কোনটাকে?
See this log p of y given x. I have to put the value of log p of y given x. We have already found the distribution of p y given x, right?
Theta
Yes or no?
star is equal to argmax
Okay.
1 by n summation of all those log p of yi given
Okay.
xi.
So what is the,
Theta.
now my question is, what is the density of Bernoulli? What does this say? I will first, let me write P only. I have already done this before. If people who have been following me, I've already done this once before. Probability
y
of
to the
yi equal to 1 is equal to, okay, y to the power or y to the power. I'm just giving you a hint. Yi is
Power
equal to
yi,
0 is it? Huh? P to the power?
p to the power yi into 1 minus p whole to the power of 1 minus yi.
Is it clear to everyone? Why is it? Put the value of y equal to 1, you get p. Put yi equal to 0, you get 1 minus p. Yes or no?
Yes.
Clear? So now I can directly put this value in the equation. What will I get? I'll get, so question number 1 is solved. W star is equal to argmax of W 1 by n. Are you seeing? Is everything connecting now? I hope if it is connecting now, it is the most feel good factor thing you can experience. So what is the value of P in our case? Let me,
Sigma W
W
transpose
transpose
X.
x.
okay, I will just represent sigma xi or sigma xi as mu xi as equal to sigma W transpose X. Okay. Just for simplicity of calculation, like not writing this entire thing, I'll write mu I. Okay. So mu I to the power of yi, right? 1 minus mu I to the power of 1 minus yi. So what does this become? Argmax, or let me write argmin. I like argmin. I've already shown gradient descent, right? We have learned gradient descent in the previous few classes. Therefore, argmin is easier. We have seen descent is easier to compute. Therefore, I'm writing a descent direction. I'm mixing up numerous subscripts and superscripts. Please forgive me. Is this okay? So this is called the binary cross entropy loss. So if you minimize this loss, you are going to get the W star. But unfortunately, you don't have a closed form for this, unlike linear regression. So what do we have to do? We have seen this in the previous class. If there is no closed form, what do we do?
Gradient descent, or we use calculus.
Yeah, calculus only. Gradient descent is calculus, of course, but there is no closed form for calculus. Like putting y equal to 0, you won't have a closed form. I'm telling you it from now. Because you have these sigmoids, right? You will not be able to separate x and y's. That's my w and x. Right? Once you take the derivative of sigma z, it still remains sigma z. I'll show you just now. Let's take the derivative of the loss. So what is the, so we will have to write, so we have derived the MLE estimate, binary cross entropy loss we have estimated. Now we will do the gradient descent. Now, just a side note, say you are not getting, side note, kernels and features of higher order. So linear models you can use. So I told you last day, just if you're not following, don't follow. It's not independent. It's independent of the topic you are doing. So say you have D features, but the data is not linearly separable or something. You cannot explain the data linearly. So then W transpose X won't work, right? As a model, if it is a linear regression model. Say your squares can explain it. So they say you have a curve like this that explains the data, right? So let us, for simplicity, take one x only, x and y. So how many? So can x explain this data? So you say this is the data you have. If you're not understanding, please ask. This is the data I have with me. X comma y's. Say you have to do a linear regression. Can y equal to x explain this? Y equal to x will be something like this, right?
No.
So I need this. So how can I get this? So this is how many degree polynomial?
Cubic.
It's a cubic. Two minimas, two extremas are there. So I would like to have ax is x cubed plus bx squared plus cx plus d equal to 0, right? Equal to your model. You're equal to y, right? Yes or no?
Yes.
So now I had only x, but you can convert x into 1, x square, x cube, and then do W0, W1, W2, W3 or ABCD. So any data you can take if you're trying to do linear regression or linear regression, logistic regression. If it is not explaining, you can take higher orders of the data, the squares and cubes and multiplication. So you can also take, say if there are x1, x2, you can take x1 squared, x2 squared, x1, x2, all those things you can stack up into form a longer vector and then predict. Okay. So this was a side note. I forgot to mention it before, but here also it's relevant, so I mentioned. So now I have to do gradient descent. So 1 and 2 is done. Number 3, do gradient descent. How do I do gradient descent? What is the step? W. So for W, I will be writing it square in angular brackets, the time point. Wt plus 1 is Wt plus minus eta times the gradient of the loss. Yes or no? Is this okay? We saw this algorithm. This algorithm worked. Must. And this is also a convex function. You can check. How can you check it is a convex function? What did we do last time?
Jensen's.
We did Jensen's inequality, but how do we check? We showed that dl d2 squared dx2
Oh, yes, yes.
is greater than 0. You can just replace this instead of you can just write wx instead of w transpose x. Take a linear case, 1D case, and you'll see it's a convex function. What happens in convex function? Unique minima. All these things we saw last Tuesday. So if we do gradient descent, we are bound to get a unique solution, right? Okay, let's do gradient descent. If you have not, you don't remember, please go back and check. Now, what will I do? How will I do gradient descent? Is my question. So what is the loss here? What is loss of W? Can you tell me? What is the loss that I want to optimize? W star is equal to argmin of the loss, right? What is the loss? We already derived it, right? What is the problem? Please.
That summation function.
Okay. These things are very important, very crucial. You'll have to, this will be given directly. So now I know this is the loss function, right? I also know what is mu I. Let me write down all the equations. Sigma of W transpose xi, right? Yes or no? Let me write it simpler. Is this okay to everyone? If it is clear, so this is my logistic regression algorithm, logistic regression algorithm. What is the doubt? Please ask. I'll wait for a minute. Because till this point is concept. Now I'll teach you how to do this, how to compute the derivative. Clear to everyone? I can go forward. Okay. So my question is, how do I compute? So what do I need? I need dw. This is what I need. How do I compute? This is my question. So what does this mean? This is equal to dl tau w1 w0 dl tau w1 dot dl tau w d, correct? D dimensions. This is what I want. All the derivative along all of the coordinates. Right? So now how do I get this derivative? I have to do chain rule, right? I have to take first dl dw dl dw dw d something and so on, right? What is L a function of? What is L a function of? W. Okay. First, your L is a function of W. That is true. First, L is also a function of mu's also, right? Mu i's. Yes or no?
Yes.
Yi's are constant. Mu i's are is a function of, and mu i is a function of zi. Zi is a function of W, right? Xi's and yi are given to you. Okay. So now I will draw a simple way to represent this. Say I have W1 or W0, W1 dot W D. All this I'll be putting to this node. And this node has access to X. So what will this node give me? Output. It will give me Z, yes or no?
Yes.
So I'm seeing this equation on the last. So now after I have access to X, Z, what will I pass it through? Sigma, and I'll get access to mu I, right? Clear? These nodes are nothing but functions. And then I pass it through the loss function and I get L of mu I. Yes or no? Is this clear or not clear? I take the W's, do the dot product with X, I get W transpose X, pass it through sigma, I get mu i's, and I use the mu i's on the loss function. Loss function is this function, right? Cross entropy loss. This is all this now I what is the end goal I want? DL DWJ, right? The J derivative I want. For each of these weights, I want a derivative, yes or no? So that I can do gradient descent.
Yes.
So how can I get that? So if I say do the first step like this, I write say dl d mu I. Then I do the second step backwards. I'm doing backwards. So this will be very useful in MLP. It's called backpropagation. Right? Forward pass, you have to do a lot of housekeeping if you take the derivative not in the correct order. Then what will I take the derivative of respect to? Is this clear to everyone? This is the loss for the ith training example. Clear or not? Now see, chain rule is applied, right? So dl, d mu, dz, dz, dw. So that is nothing but equal to dl, dwj, right?
Yes.
Right? This is a chain rule, right? Just if you do not remember chain rule, you can just sort of cancel continuously. Although that is terribly wrong thing to do. Now tell me what is dl, d mu? First step is dl, d mu, right? Tell me. Both are i's over here.
Like from that equation, summation 1.
That you will have to tell me. I want to see if you're following.
Yes, then yi by mu I plus 1 minus yi.
yi by mu I minus
1. Yes, 1 by 1 minus 1 by mu I. Yes.
okay, this is the ith for the ith data point. I'll just remove I and put the summation. There would be no, for the time being, let's keep I. It will be useful later on. Okay, so this is the derivative. Now the second derivative, what is the derivative that I need? What do I need? So
With
this
that
I already,
sigmoid derivative.
yes, we need d mu dz, which is then nothing but the derivative of sigma dash zi, right? This is what we need. So dd x of 1 by 1 e to the power minus x at x is equal to zi, right? So what will this be? Is this correct?
Yes.
So I will add 1 and subtract 1. This will give me 1 by sigma z I minus 1 by sigma zi squared, right? What have I written? What 1 by, right? Is this clear? If you're not clear, then 1 by 1 plus e to the power minus x minus 1 by 1 plus e to the power minus x whole square. Okay, now there's nothing to be clear about. Now do you see that there is no closed form? The derivative does not have x and y separable. So these are all depend on w. All depends on w, right? Yes or no? So this is 1 by 1 plus e to the power minus w transpose xi, right? Can you separate this w and x and get the values of w? You can't. Okay. If you're not following, not interested, I can't do anything. So now you tell me, what is zi? Zi? Tell me this, what will it be? What will this be?
All those xi.
Good. Not just see correctly. W1,
Xj, sorry.
x1, xi1, w2, xi2, dot, 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 dot. So I will get xj, right? Of the ith example. Yes or no?
Xj of the ith example, yes.
Does not yet come. So I will put all of these together now. Let us put all of these together. So your gradient d with respect to w, dl d. So this is 1, or rather 3. This is 1. This is 2. Let us just put everything together. So it is 1 into 2 into 3. Sum over all the examples. Let's do it. So 1 is 1 by n yi by mu I minus 1 minus yi by 1 minus mu I, right? Into, see, mu I into mu I, 1 minus mu I, correct or wrong? This is what? Do you agree with me?
Yes, yes.
And what is number 3? Clear? So what will it be summed over? All the training examples, yes or no? Linearity? Derivative is linear. You can sum over all the training examples. This is for one training example. One example. And for n training examples, it will be summed over n. Is this clear? If you're not writing it yourself or seeing closely, it's not be clear.
Dada, like, won't you vary the J1? Means
See,
J
now that's exactly a good question to ask, but consider I shouldn't have written this. I should have written DL DWJ, right? We'll vary that as well. Is this clear? This is the J's derivative, right? We are taking the J's derivative currently. We will also do it for the other J's, right? This is
yes, okay.
This is for the J's derivative, which is equal to 1 by n summation of I is clear, right? We did it for one example and continued for all the others, because this loss is a sum of all those losses. See, I is the training example, J is the features, right?
Means for each feature you added up all the losses.
Not, this is for each training example I added up all the losses. Just check this equation. Change this equation. These are all I's, right? Correct? These are all I's, yi, mu I's. These are all for one example. Bernoulli, yi, w transpose xi. Again, I have slowly made error in notation. Okay.
Yes.
So for all of the n examples, it will be sum of all those, right? Now what will I get? I'll get yi into 1 minus mu I plus 1 minus yi into yi into xj of I. This we have already done in linear regression, this form. You will have to tell me what is it. But anyways, let us solve this. So what gets cancelled over here? You get yi minus mu I xj. Is this clear? Yes or no? Can I vectorize this, write it as a vector, directly get the answer? Can I do that? What is it summing over?
Like y minus mu transpose into x, something like.
Very good, very good. So it's not exactly that. So if I want, it is right. It also depends on what vector do you want. If I want this dl dw0 dlw1 dl wd. If I want this, then x's have to be right. So if this was your training example, x1 all the training examples, x2 all the training examples, dot 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 x j all xd all the training examples. So this will become, what is the dimension of this matrix? D cross n. This is x transpose, right? First feature, dth feature. Similarly, y minus mu I will be what? Y is a vector. How many dimension? N cross 1. Yes or no? Minus sigmoid of W transpose X. X is N cross what? N cross D. W is D cross 1. Is this okay? N cross D plus 1. Forgive me if I okay. Is this clear or not? So I can write 1 by n x transpose y minus. This is my derivative. So my gradient descent update will be wt plus 1 wt plus, or I can even write minus eta by 1 by n x transpose. So there is a very intuitive explanation of this. Can anyone tell me what is the intuitive explanation? This is my update function. I'll show it today when I show the code how it works. So this is what? This is the predicted y, right? Yes or no? In many books, you will see it is equal to y hat. They write. Yes or no? This is the predicted y. Sigmoid of xw is what you're predicting.
Yes.
And this is the actual. So this is nothing but the error. So the error is corrected. So they say you will see new machine computer scientists say you see the loss and tweak the parameters based on the error. So this is also equal to saying I equal to 1 to n delta I. You take the weighted average of each of the error from each. right? For each feature, you see how much error is that more training example doing, and you take a weighted average for each feature. Is it clear? Is the intuition clear? This is the actual. This is the predicted. Okay, so if it is clear, once my model is trained, I get W star. How do I do inference? My question. How do I do inference? Inference, yeah.
How is UI a predicted Y? It is just a probability.
That's what I'm saying. It's a predicted Y only, no? So this is probability of Y given X.
Yeah.
So this is the probability. If greater than
YI
0.5, YI is the actual YI, right? That is the
it's the
training
actual
data.
which is
You should train the data X
I'm
comma.
তো মানে saying that মানে YI UI টা তো তাহলে YI cap ঠিক হচ্ছে না গো। UI টা তো probability হচ্ছে
So
একটা।
cap is a probability. It's not. It's logic. It's not 1 or 0. It's not one hot encoded. Mu I is not. It can, if it is this, then I will give. So if you want this as the notation, very good. Go ahead. Okay. If the predicted value is greater than 0.5, I say that it is more likely to be class 1. If it is less than 0.5, I say it is more likely to be class 0, right?
Yes.
So that's why. So this is a soft version. So this is just called a soft prediction. Not a hard prediction, but it is also called it's called a soft prediction because you're not giving zeros and ones but probabilities, which is essentially the same thing. We'll see just now softmax and we will confirm that. But it is the other derivation gradient isn't clear and why we do not have closed form clear. Artho?
Moinang, I didn't understand that মানে এটা একটু হচ্ছে না clear যে YI minus UI তো YI will be 1 or 0 but UI is the probability of being 1 or 0. So how am subtracting
1 or
them?
0 na probability of 1. Probability of being 1.
হ্যাঁ,
That is a
probability
single
of being
number.
1.
Yes. So if it is if yi is 1, for error to be low, I must have large yi. Error is yi minus mu I. If this is 1, what should the model try to do? It will try to send this to 1. Then only will the error be 0.
Yes. Acha,
Still
so
not,
if it is greater
still
than
not clear. You are optimizing this variable and you are, when will it be optimized? When delta goes to 0. This can never, this can never be. So gradient is, you're trying to optimize. Gradient has to go to 0, right? Gradient, if it is 0, it means it is an optimal point.
yes,
So that if it is going to 0, if it is 1, then what will mu I is go to? At optimal?
it would go greater than a 0.5 means towards 1.
I don't why greater than 0.5? If it is W star, what it should be ideally at W star, what should be mu I?
W star, what should be?
At the
should be
close to 1. It should be confident about its prediction.
close to 1, yes.
Similarly, delta I, if yi is 0, then where it should go?
Close to 0.
Similarly, you can see this from the loss also. See, when y is 1, only this part remains, right? I'll just write the log likelihood once again. Yi log mu I 1 minus yi log 1 minus mu I. This is for one training example. My question to you is, what happens when yi is 1? What does the model have to do with this loss? To minimize the loss, what does it have to do? This is clear, very clear from these equations, right? What is difficulty?
The second half is cancelled.
Second half goes to 0. This is
Yes.
0. And this is just log mu I. And this depends on W. So now what has to log? So this has to go to 0 also. This can only go to 0 if mu is equal to 1 or tending to 1. Yes or no? If it was close to 0, then it would have given you very, very large loss. Yes or no?
Yes.
Let me write minus log if it is not still clear. This is minus log x. So if it was very close to 0, then you would have infinite loss. So you have to optimize to get close to 1. For the ones that are 1, you will send them to 1. For the ones that are 0, the model will automatically send them towards 0. And that is guaranteed by the soft error that you encounter.
Fine.
Okay. So we have done this as well. Can you do it for the entire batch all at once? That's my idea. Say you have n going to 10 to the power 6. Can you compute gradient descent for all of them and do one step update? That's my question. 10 to the power 6 may not even fit in the GPU. So can you do that? Compute derivatives of all 10 to the power 6 and then update. It will become very slow, right? It's an iterative algorithm. You want to do faster updates. So we take batches. Say normally 32, 64 or 128. So you break the data into batches. So if there are say 100 data points, you will break them up into say 10 batches of 10, for example. Right? And then for each batch, you do gradient descent. Right? For all batches, do W minus eta dl dw for the batch. For batch bi. Right? When you complete all the batch for n epochs, complete all the batch and then restart. So once you complete all the batches, this is called one epoch. Right? This is called one epoch. Generally, you measure how many epochs do you train your model on. Right? So first gradient descent step you will do on this, then you will do on this, this. So you will do say 10 steps of gradient descent. So this already you have 10 steps of the gradient. And you will then complete one batch, one epoch. So normally if you see, these are very important questions. You would have loss like this for normal gradient descent, full batch gradient descent. That is whole data set data. And you will have you will have stochasticity. You will have a noisy version of this. I'll show you why. If you have batch gradient descent, and the worst case is this is called stochastic gradient descent, where batch size is equal to 1. Okay. Any questions? So this is called mini batch and stochastic gradient descent. I'll wait for a minute. Is it okay?
After one epoch, means you will
Okay.
train with these batches again, means same way
Yes.
divide.
Exactly. So normally what you would do if say batch size was equal to n. So this is called a batch size. Batch size is equal to 10 over here. If batch size was equal to n, then it is normal gradient descent, just gradient descent. Batch size is equal to 1, it is stochastic gradient descent. We'll see why. We'll again start, right? We'll start until w minus w, wt plus 1 minus wt is less than some epsilon, right? Or you have said you want to do for 100 epochs and see, right? Is it clear to everyone? Normally, before you do the batch gradient descent, to prevent iterations, prevent repeatability, you permute the batches, you permute the training examples. Permute training examples at the end of each batch. Once you permute them, now you will have different sets of xy, right? Yes or no? You will not have the same batch
Yes.
contents. So that will sort of prevent your stochasticity, reduce your stochasticity. So these are all design rules. So okay, my question to you is show that stochastic gradient descent is an unbiased estimator, or stochastic gradient is an unbiased estimator of actual gradient. Can anyone tell me how? This is the fourth question. So we have done stochastic gradient descent also. Now show that it is an unbiased estimator of actual gradient descent. How do I do it? What should I do? So
Take
now,
the expectation of all over the entire data set of the gradient with respect to a single xi.
okay, let me write it as we wrote Li W Xi Yi. This is what L depends on, right? Yes or no? Do you agree?
ये लाई क्या ना लिख लेगो?
Of the I loss, total loss. This is the ith loss.
ओ अच्छा ith loss हाँ ठीक है.
Loss of ith example. Okay, so this is the sum of all the losses of all the examples. So this is, tell me what is it? 1 by n yi log of sigma of w transpose xi ball.
Plus
Not
plus
plus,
1
minus.
minus
Both are minus.
minus 1 minus yi log of 1 minus sigma of w transpose xi.
Yes. Is gradient descent clear to you? With stochastic gradient descent?
Yeah.
Okay. So if it is clear now let us fix this is fixed for the time being. What are the random variables in gradient descent? What are the random variables? Just tell me what is randomly selected in stochastic gradient descent. What is stochastic about the stochastic gradient descent?
The point.
Data point xi comma yi is the random variable. Good.
Yes.
So
Joint
I can
distribution.
no, that is okay. That is data distribution. That is different. But this is another. This is uniform 1 2 dot n, right?
Ah,
So
every one has a chance of 1 by n being picked.
yes. So my normal gradient is this. Normal gradient should have been this. Now I tell you what is the expected value of L x comma y. This is what I want to find, right? X comma yi given x, or let me just write x comma y given x, right? Or just you can just write expected value. This will do. So what is the expected value? So I will.
Expected
This
value
is
over all x and y's.
okay. So this is lotus one. So what is the probability that I is selected?
Linearity
Probability of I is selected. What is the probability I is selected?
1 by n. 1 by
1 by
n.
n. 1 by n. So by lotus, I have one probability I is selected. I is selected. Loss of w xi yi. So this is nothing but equal to 1 by n summation of 1 from 2n loss of w xi yi. This is nothing but equal to gradient of wl. Clear?
Clear.
So the expected value of L given x comma y is nothing but this.
Gradient of the actual gradient.
Yes. Or you may not even write because x, what is actually given to you is x comma y. That is true. But you can take, I think the outer one is enough. You don't even need to put the conditional. Okay.
Batch gradient টা তো এমনিতেই হচ্ছে unbiased estimate.
Batch gradient is again the same thing. You can select batches. Now each batch is randomly selected, right? Batch gradient descent. Mini batch gradient descent is when you have n k samples. K is
If there are
64,
n number of samples and k is the batch size, then every batch has a probability of k by n. Then
same, exactly same way. And you can even shuffle between batches. So that also is unbiased estimator.
shuffle between batches মানে?
At the end of the day, you will also shuffle between batches, right? You will be selecting. So you don't even need to shuffle between batches. You can just select k of them, any k of them, and it will be the same estimator. At a particular, you don't even need. So for an update, it's like k of them. But anyways, so the question that I want to ask you, number of gradient descent steps done if number of examples is equal to n and batch size is equal to k. What is the number of examples? Number of steps you will do? per epoch. Batch number of examples is n, batch size is k.
N by
Right?
K?
N by k. But be careful with n by k. See the base case. If there are 10 examples and 6 batch sizes, 6 is the batch size. Then how many
Floor nebo
updates
ki?
will you? How many updates? Careful again. Ceiling.
Ceiling.
6,4 will be the batches. So this is the number of updates per epoch.
Muinagda.
Yeah. Tell.
Actually means I had a still impending doubt, if you won't mind. Soft error ta niye.
Yes.
আমি না মানে আই এম নট বিং এবল টু কম্প্রিহেন্ড দিস যে মানে তুমি যেটা এক্সপ্লেন করলে আর একটা বার আই উড জাস্ট রিকোয়েস্ট ইউ টু এক্সপ্লেন যে মানে এই সফট এরারটা যে হচ্ছে ওয়াই আর ইউ কলিং ইট সফট ফার্স্ট অফ অল কারণ প্রেডিক্টেড ওই জন্য কি
Soft is because it's not 0 or 1. It's the probability. You're not going to put y hat as 0 and 1 there. Yi is at the probability. Anything greater than 0.5 will be very close. It will be closer to 1. Anything lesser than 0.5 will be closer to 0.
ও এই জন্যই আই থিঙ্ক উই সিলেক্ট দ্য sigmoid function যাতে যখন it becomes closer to 1
Sigmoid function was
it is
selected when because we wanted to convert W transpose X, which was from minus infinity to infinity, to 0 to 1.
yes
Minus infinity to 0 was to between 0 and 0.5, and between 0 to infinity from 0.5 to 1. This is why it was selected, not because of the other reason.
আচ্ছা
First, we did MLE. We found out the Bernoulli distribution. For every point, we want to toss a coin with some probability and say if it is in either distribution with some probability, something like that. And we found out the Bernoulli distribution's parameters was dependent on the input of the data. Please go back and have a look at it again. Anyways. Now we'll extend this to K classes. So if we have to extend this to K classes, what will I do? I'll just derive the loss function and will because it has the same form. You can do the derivative at home. Now what will I have to do? Do you remember the discriminant function that we did? Do you remember the discriminant function that I did?
yes
Say I have K classes, right? D1 of X, D2 of X, dk of X, right? I want each of them to give me, what do I want? We have done this in the previous classes. Probability of y is equal to 1 given x comma w.
given x and theta
Is this okay? Clear? This is what I want. This is the discriminant function logic that I had used.
yeah
So I can write this first function as, say, let me put i's on the top, w 0 w 1 0 plus w 1 1 x1, w12, x2, and so on, right? So now W becomes a matrix instead of a vector, right? Where W is, what is W? I have k classes, right? Previously I had a vector, only one class. In binary classification, I had only one W, yes or no? One W vector in R d plus 1. And this is d plus 1 cross k.
বুঝতে
Because
পেরেছি।
I want to do it for each of these nodes.
হ্যাঁ, কারণ it is the W for D1 basically.
Okay, W k is the, or I'm putting a colon also at the beginning so that it's all the rows you can understand. W colon comma k is the weights for the kth class. I shouldn't write kt for the tth class. Okay, is that okay?
মৈনাকদা, তাহলে তুমি যেখানে p of y equals to 1 such that x, w লিখেছিল, ওটা w01 plus w11 plus 21 হবে না এভাবে?
W is everything. W is the W matrix.
ও,
Whatever is essential you take. Wherever is not essential, say x is
না মানে
independent of y.
যেগুলো তুমি, না মানে যেগুলো তুমি w i আর j লিখছিলে ওটা
Yeah, it was
01 হয়ে
implied.
যাবে না?
For example, 01 will be colon 1, colon 2, colon k.
না মানে যেখানে লিনিয়ার কম্বিনেশন হিসেবে লিখলে সেখানে w10
Okay.
লিখেছিলে, ওটা
Yeah,
01
01.
হবে?
Yes.
হ্যাঁ, ওটা
01, 11, 21, and so on. Right? This is what you're saying.
ইয়েস।
Correct. So now, again, this is another issue, right? So this I want to be probability 1. This is I want to be probability 2. I want probability k. But what has to be summation of pi? 1. And pi's have to be greater than 0, right?
Yes.
How do I ensure that? How can I convert any number between 0 and 1? Minus infinity to infinity to between 0 and 1 or greater than 0? I can do.
sigmoid function.
We can also do something like proportional to wx. Say pi is proportional to wx. Okay, e to the power w transpose x. This is greater than 0.
মাইনাস w ট্রান্সপোজ x হবে না?
I am putting w transpose x only. I don't like minus here. Just for one reason I'll show just now.
Okay.
If I write w transpose x, do you agree this is greater than 0? E to the power w transpose x.
হ্যাঁ, অনেক গ্রেটার।
Not onic. It can be negative, positive, both. It is symmetric. Minus also if you put, positive also if you put, they're same thing. They're not different.
Yes.
This term is between minus infinity and infinity. So this has to be between 0 and infinity, e to the power. So what will be pi? It will be e to the power w transpose x summation of is this clear? The probability of the ith class will be nothing but this is the scaling factor, yes or no? If this is also not clear, I can't do
Oh.
anything. This is
Ha. Since the sum will always be 1 to ensure that.
right. Everyone.
Yes.
So this is called a softmax function. This is same as sigmoid, but in multidimensional case. So this is what distribution will this be? Multinomial distribution, right? Binomial, multinomial. Why? There are k options. Okay. So now you tell me for w equal to 2, k equal to 2, you should be able to show that this is same as softmax. So if I put w equal to 2, probability of 1 is e to the power of w1 transpose x divided by w1 transpose x plus w2 transpose x, right? Yes or no? For k equal to 2 classes.
এটাই তো আমাদের লজিস্টিক ফাংশনটা।
Right? Because this is not learned separately, so you will get only, you can replace this by a single w. Right?
Yes.
This is the same thing. So this is called a softmax function. Now, what is the probability of, if I am telling you to write probability of yi given xi, comma, w. So if I first tell me what is the distribution, multinomial, what will this be? Multinomial. So I will represent this as, say, sx. This sum, because that is constant for a particular training example. What will it be? What are the probabilities? Probability of y equal to 1 is e to the power w1x by sx. What is happening? Tell me something.
Acha, these are the PIs.
Yes.
টু
This
হলে
is how you
এটাই
write.
কি বর্ণলি হয়ে যাবে?
Yeah. But 2 means
Oh.
1 and 1 minus p. It's Bernoulli. One gives enough information about total information about the other. But more than 2, it. So this is multinomial case. Now my question to you is, how can I write this as? So do you agree I have to write log p? So my idea is to do w star as argmin of w. What? Log of p of y given x. Yes or no? This is what I want. So what is this? Is what? 1 by n. Do you agree?
Yes.
So this is just the MLE. My question is, what is p of yi given x?
ম্যাক্স হবে না ওটা? ওই না তো ওটা আর্ক
Yeah,
ম্যাক্স
yeah.
হবে না?
Okay, happy?
Yes.
Tell me. What is this? I already know that distribution form. How can I write this as?
Multinomial.
So I will let us write this as mu I 1, mu I 2, mu I k. Okay. So the training data has to be arranged accordingly. I will say a data belongs to the ith class if the ith value is 1 and rest are all zeros. Okay, this is my yi. It's a vector and not a number. Okay. Ith position equal to 1. This is called one-hot encoding. Why is it called one-hot encoding? Why will it tell me? It's in the name itself.
The correct class is basically denoted by 1.
Rest are all zeros. Now, if it is denoted by 1, tell me in 1 second what is the what can I write the probability as? Can I write this?
Oh, huh.
Everyone?
Yes. Yes, yes.
All will become 1 except
Except
y,
the correct class.
y actual. Right? Say for example, k is actual classes 10. So you will get mu I, mu 10 of I, right? Into all our ones. Clear? Because all these numerators will become 0 as only y10 is equal to 1, rest equal to 0. Agreed?
Yes.
That means you are breaking the Y matrix into these parts, Y1, Y2, Y3.
Yeah. Yes. This is y1, y2, yk. Okay. Anything in the subscript is the dimensions, are on the dimensions, and anything on the superscript is the training example. So now tell me what in one line. What is this value? We'll just put, this will become summation of j equal to 1 to k.
J equals to 1 to k, huh? Yki log
Y
uki.
k I j, not I j log of mu of ij, right?
Yes.
This also, if you take derivative, you can get the gradient of L is x transpose y minus sigma of xw. This is also the same you'll get. But here the dimensions you'll have to be little bit careful about. What is the dimension of x? This is your homework.
Oh,
Right.
same x supposed to
K cross x transpose is k cross or d cross n.
d cross of k. D cross n, sorry.
Y
D cross
is
y is k cross 1.
others. What is y?
N categories, so 1 cross n.
Not n category, n cross k. In training examples, right?
Acha, yes, yes.
In training examples, y1, y2, dot, 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 yn. Each of them will be a k categories. K categories. So it's n cross k. X is again n cross d. W is
D cross K.
d cross k. See, d cross k I took initially. D plus 1, whatever you want. I'll just put d plus 1. Okay. So you will get the derivative for d plus 1. So this is equal to, and you will have to sum over all the training examples, right? So that is being done. D cross 1 cross k. The dimension is d cross d plus 1 cross k. That's what you want. You have this many weights, right or no? The gradient of L will have this dimension. Any
Yes.
questions? Okay. So with that, I'll stop. I could have done these two also. I'll try to do it in a fresh mood. I'll just now show the code for how to code this multinomial regression in Python, so that we are having both theory and practical, as people had suggested. Is the thing clear? I'll wait for a minute or two, and then if you have any questions or doubts, I'll answer them. Anything to do with the loss? So what are the steps that we did? Can anyone summarize the steps to find out the model? Where did we start from? What was the assumptions? What were the assumptions? Can you volunteer and tell me? It'll be easier. It will be like a good thing for you also to.
Like there is a line, and on one side
Okay.
exists one class, and on other side the other. And
Exists.
this line,
Okay.
this line are in multi-dimension, that is plane.
Okay, but then how are we fitting the line is the question, right?
Yes, yes.
So we do not know how to fit the line, but we have seen in the previous class that there's something called as a, what is it called? Maximum likelihood estimation. In maximum likelihood estimation, we maximize the probability of the data given the model, right? So we have to maximize the probability of the data given the line. That will give me the best line, right?
Yes.
So and then I see y given x is a Bernoulli random variable, because we want to introduce the w's, right? W transpose x. We want to represent the prediction in terms of the W transpose x. So now we saw that W transpose is greater than 0. Therefore, we put like from minus infinity to infinity. Therefore, to make it between 0 and 1, what did we do? We put
We use the sigmoid function.
We use the sigmoid function. Please go now. After using the sigmoid function, we wrote down the entire algorithm. Where is the entire algorithm? Here you go. You wrote down the entire algorithm on the left hand side. And what did we do? We took something called backpropagation to compute the gradients in a simpler format, because it was easy to calculate the derivatives directly with respect to the variables it depended on, right? And then we found the closed form of that. And we saw that it was, you saw gradient descent. We did batch gradient descent and showed that it is an unbiased estimator of the gradient. Finally, we did multiclass regression, which, what are the few concepts that the multiclass regression use? Partho, since you did that class before, what are the few concepts that the multiclass What are the concepts that a multi-class classification uses?
The linear discriminant function concept.
Discriminant function. All the things have to be like discriminant function, and whichever gives me the maximum value, I'll predict that, right?
Otaku I'll choose. That means argmax
So, oh, I
of all of
forgot.
them.
Yes. So what will be my prediction? Again, it is called softmax because it gives me probabilities and not actual wise. Again, you
Not
see
actual value.
the gradient is again soft.
Acha, then linear discriminant, I can also say softmax classifier.
This is the software that is also linear. Discriminant is not. We were taking normal distributions there, but it depends on what your
Yes,
model is. How
that
do you
is
do
also
infer?
probability. So I can also say it is softmax, na?
Where?
Means the discriminant function we did earlier, that G2x is equal to G1x, the
But
decision
the
of
G's that we took, they were not linear. Those were normal distributions. They were quadratics.
মানে ওটাকে I can't say as a softmax, কারণ after all the probability.
Soft, it was probability, but it is not. Like I don't know how technically you can say that. It's a density more than softmax.
আচ্ছা,
So, and there you assumed the class. You did not learn anything. So you assumed you learned the mu's and sigmas though. Anyways, so Oshmit or Utrich, can you tell me how do I do the inference? Inference as in I give you a new x, new data x. You have to tell me the class. What will I do? What will you do?
Means try to get the value of y, means by the probability.
But what is the model going to give you? D1x, D2x, dot 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 dkx, right? K outputs it will give you, right?
Yes.
So then how will you say which class does it belong to? Yes or no? The value which is maximum probability, where you will assign the data point to that class, right? Like voting system. Whoever get the maximum percentage of votes will be declared the winner of the vote, right?
Yes.
All of them are outputting probability P1, P2, and sum is equal to 1. One of them will have maximum probability, yes or no?
Okay, means that point belongs to that class.
Yes. That's how we trained it. Please go back and see the derivation and the definition. It will be very useful and it will also help you understand probability well. It gives you a backward reinforcement once you are able to do it. Okay, so I'll stop the screen sharing from my tablet and I'll show the. I'll stop screen sharing from my tablet and I'll just share my code. Can you see my screen? Is my screen visible?
Yes.
So now I'll show you how to code this. I'll just keep this thing open. It is required by any means. I'll just, yeah. So the final derivative we found out was here. Okay, in case we need it, we'll have a look.
Moinakda, I just had to
Yeah.
ask one thing, which is the softmax multiclass classification we learned, the model assumption over here was that the probability that x belongs to the class I, let it be proportional to e to the power of something. So
It is just some function of W transpose X such that it gives me greater than 0. And greater than 0, you'll see anyways in optimization, it's always the best function is an exponential function. Exponential function will give you a greater than 0, right? And it's more the yeah
oh acha, fine.
probability,
Probabilities.
right?
Okay.
Okay.
কিন্তু greater
So
than 0 and less than 1 ও তো হতে হবে, এই কনস্ট্যান্টটাও তো রাখতে হবে গো।
I couldn't hear you. You were lost. Huh?
না মানে greater than 0 এর সাথে সাথে less than 1 ও তো রাখতে হবে।
That's why we did proportional, না?
ও আচ্ছা।
আরে সাতকান্ড
And
রামায়ণ
then
করে
we
সীতাকার পিতা।
না then we set k to that regularizer term, fine, বুঝতে পেরেছি।
No regularizer. It is proportional to this. It is the proportionality constant. Class 3 maths. In class 3 they teach.
হ্যাঁ হ্যাঁ
What is the value of the
yes,
proportionality?
that is 1 by যাতে সবকটার addition 1 হয়।
Yeah.
ঠিক আছে, বুঝতে পেরেছি। আচ্ছা, can I use this default format for any multi-class classification using any
Yes.
model?
You just have. This is exactly the same thing. You just change the model. Instead of having W transpose X, you have a linear. You have a neural network. You have anything you want.
Instead of exponential আমি অন্য নেব।
Exponential always. Exponential will always be there. Your model is W transpose X here. If you recall. That is the probability that you're getting. This one.
আচ্ছা।
Your model is W transpose X, not e to the power W transpose X. E to the power is just to get probabilities out of your model. You can think of it as a model, but anyways, where is this thing, right? That I'm highlighting. That is your model, right? Your model is W1 X1 plus W2 X2 plus W1 Xn. This is your model.
আচ্ছা।
You can have any neural network over there, and still that will also give me a number, and then you can have e to the power of that. You can have, we'll see. So this MLES formulation does not change. What changes is this W transpose X ke jagah, you can have any f of X, f theta of X.
Like for example, what f of x একটা example দিলেই বুঝতে পেরেও।
Neural network is an example. And
আচ্ছা।
MLP is an example. You can have any f of X. MLP is an example. CNN is an example. How many examples do you need? Any function that you write x for x squared plus x, any function is an example.
ও আচ্ছা, হ্যাঁ yeah, it's clear now, বুঝতে পেরেছি।
So now I'll show you how to what I wrote as a code. I just recently, this was originally a logistic regression, but I'll do a softmax regression for better understanding. So I'll load a dataset called the iris dataset. Is very simple. So the dataset is not that important here. So it has 3 types of iris class: the setosa, the versicolor, and the virginica. They have different sepal length, the petal lengths. So the sepal and the petal size can be used to categorize these flowers. So that's what I've drawn over here. I've printed over here the sepal length, petal length, and so on. So you have 3 classes: 0, 1, 2. 0 is sentosa, 1 is versicolor, and 2 is virginica. 0 is setosa. Okay. Now what do? I load the data, and since I want to have better visualization, more than 2D will be difficult to visualize, right? Do you agree? Like for the time being, I have only selected sepal width, petal length, and petal width. These 2 I have selected as the features to predict if it is which in which class. Okay, are you okay with it?
Yes.
Hello. This is what I've selected. So ID's data gives me the data, and these gives me the columns I want to select. And then I just concatenate these two columns with a one column, right? I want ones and the beginning, right? I want one and then the two features because I want to have the bias term also. Yes or no? So this is
Yes.
np dot concatenate concats two column vectors. So np dot ones, this shape will give me a column vector of, this will make me a column vector like this. Array, what is it? I can't. So this gives me a column vector, and this is already a 150 cross 2 dimensional matrix. I concatenate them to get 1, x as my feature matrix. Similarly, y is the target. It can be 0, 1, or 2. And I make a one-hot encoding. How do I make a one-hot encoding? I make a one-hot encoding by, what do I do? So what are values of y? Y's can be 0, 1, or 2, right? Are you following? Let us print y and show you. Y is 0, 1, or 2, right?
Yes.
You can see. Now I convert it into np dot zeros makes it a zero shape. How many will it be? Y dot shape 0 will be 150. Yes or no? Shape 0 means the first shape,
Yes. Yes.
first dimension. And the length of y will give me length of number of unique y's will give me the number of classes.
Number of classes.
So that it makes a n cross k zero matrix. Now np dot arrange length of 0 gives me a vector. I'll show you. What does it give me? Y dot shape np dot arrange. It gives me y dot shape 0. It gives me 0 to 150. These are indices, right? I want to access. And y's are there corresponding. So say the first index is 0th class. So 0th class 0, 0 will become 1. Similarly, the 95 second index is 1. So 95, 1 will become 1. So whichever class it belongs to, it will make that 1. So that will give me zeros and ones here. And this is, you can look at this later on. It just plots the three classes separately. So you have setosa as the red points, versicolor as the blue points, and virginica as the green points, right? You will want to separate these three classes. Is it okay to all of you? So this is the petal length and petal width. You can see that they are more or less dividable, right? Agreed?
Yes.
Now what is softmax? Softmax of x is e to the power x by sum of e to the power x. That's what we discussed. Okay. Now the loss is, what is the loss? What is y hat? xw, as we have seen before. Let me just show you once again. Look at this. What is the loss? Yi's, actual yi's into predicted yi's, log of predicted yi's, yes or no?
Yes.
So I just take product of these two and sum them. That is the loss for me. No doubts. This product is an element-wise product, so there will be no problem. And softmax is the prediction for each. So I have the prediction values over here as well. So similarly, gradient we have already calculated. What is the gradient value? X transpose y minus sigmoid of xw. Yes or no? Okay. So I do.
সফট
minus
এরারটা
of
ওখানে নিলে
soft error into this. Right? X transpose into error divided by n. Now I do gradient descent for 1 to number of epochs. Here the batch size is 150. So I did not do batch gradient descent. I did it on the entire thing. I append the losses just to keep track. And I update the weights. Right? Weight minus learning rate into gradient descent into gradient of the softmax. This is how you write modular code. You just put gradient, it will give you the gradient and just update. So now, see, you get a unique value of W. W is a matrix, 3 by 3 matrix, and I plot the curve. It's decreasing to 0. And if you plot the line that is dividing into 3 places. So you see this, everything here will be told to be green. Everything here will be set to be versicolor. Everything here will be set to be setosa. I hope it gives you a good visualization of how this regression works, right? The train accuracy is around 94%. We did not do any test accuracies. If you want, you can divide the data into train and test set and see how it performs. Okay, I've shared it anyways. You can play around with it. Maybe do something like batch, convert it into batch gradient descent. Yeah.
So the class boundaries will be all those combinations. P of x1 is equal to P of x2, x2 is equal to x3, x1 is equal to x3. তাই তো?
On this point, you have this Virginica and versicolor have same probability. These at this point, you have versicolor and setosa having same probability.
Same
At this
probability.
point, setosa and Virginica will have same probability. At this point, all of them will have same probability. But these are points in a plane. They have 0 probability. They will not have any point data on those points.
Yes. Yes.
Okay. So any questions regarding the code? Any implementation you want me to explain something?
আচ্ছা মৈনাক দা ডেল এল ডেল ডাব্লুতেই আমরা সফটওয়্যারটা পাই, তো মানে যেখানে ডাব্লু স্টার হয়ে যাবে মানে যেখানে লসটা মিনিমাম হবে সেখানে সফটওয়্যারটা 0 হবে, তাই তো?
It will become 0. It will reach a minimum point. So it has converged. Loss is decreasing. Now it has converged. Loss need not be 0. The gradient will be 0.
আচ্ছা কিন্তু আরেকটা জিনিস, you told for 0 and 1, কিন্তু when we take the same software for multiclass, our
check if one increases, others have to decrease.
আচ্ছা,
Sum is equal to 1. If you want to make one value corresponding to the actual label equal to 1, others must decrease to 0, right?
হ্যাঁ, অন্যগুলো ডিক্রিজ করবে। ঠিক আছে, বুঝতে পেরেছি।
Okay, I'll stop sharing. If there's no more questions, then I'll stop recording. Next day we'll continue from k means clustering and k nearest neighbors, and we'll begin SVMs. So I hope you would like to do SVM. So we'll see you next class. Stop recording.